Hello, welcome to this video on critical path analysis. So in this video we're going to look at how we calculate earliest start times, latest finish times and float. Then we're going to look at how we identify the critical path, and then finally look at some of the evaluation of using critical path analysis. So let's throw back to last time when we had developed our network diagram. So a quick reminder, we had a number of activities and tasks we needed to complete in order to launch our new product. We had the dependents, so B depended on completing A, and the durations. And so we have a network diagram like this. We have nodes that are numbered points in time, we have activities taking place and their duration underneath. Now to complete our network diagrams, we add two more things. We add the earliest start time and the latest finish time. So let's start off with the earliest start time. What does the earliest start time mean? Well, the earliest start time tells us the earliest possible time at which the next activity to the right can begin. And we write that number in the top right hand section of the node. So we write it where we've got these quadrants. So why did I write 0 here? Well, let's listen to our definition. It's the earliest time at which the activity to the right can start. So A can start straight away. So the earliest time it can start is 0 weeks. Now let's look at the next load along. Why did I write 2 here? Well, what's the earliest time that B can start? The earliest time that B can start is only once A has finished, and A takes 2 weeks. So the earliest time that B can start is 2 weeks in. If I go on one more to the right, what's the earliest time that C can start? Well, C can start when B and A are finished. A takes 2 weeks, B takes 4 weeks, so C can start after 6 weeks. Now, why didn't I write 9 here? Well, F can start once D and E are finished, and they can begin after 8 weeks. So after 8 weeks, E can begin, which means it will be finished after 9 weeks. But F can't start then, because F also needs to wait for D to be finished. And the earliest time that D can be finished is 8 plus 3, 11. So F can only start after D is finished, which will take 11 weeks. Finally, what does this number tell us? 14. 14 tells us the earliest time at which the project can be finished. So some rules for calculating the earliest start times. We move from left to right by adding the duration of the activity to the previous earliest start time. So for example, the start time for B, we move left to right, we take 0, the previous earliest start time, and we add on the duration of the activity. So 0 plus 2 gives us 2. 2 plus 4 gives us 6. 6 plus 2 gives us 8. Now here we have a bit of an issue, because if I go via E, I would get 8 plus 1, I would get 9. If I go via D, I'd get 8 plus 3 is 11. So if more than one activity precedes a node, so node 5 is preceded by D and E, we always take the highest figure. So here we're going to take 11 rather than 9. Always take the highest figure, because remember, F cannot start by definition until both D and E are finished. So we have to wait for the longer of the two activities to finish, and that means F can only start after 11 weeks. Let's move on now and look at calculating LFTs, and this stands for the latest finish time. And so the latest finish time is telling us what is the latest that the activity to the left can possibly finish to not delay the project. So for this one, we go back, rather than from left to right, like we do with ESTs, we go back from right to left. So if the project can be completed after 14 weeks, the latest time that F can be finished to not delay the project is 14 weeks. So the 14 weeks is the latest time that F can finish. What's the latest time then here that D and E can finish? Well, they have to be finished to allow F to take 3 weeks to us to get to 14. So 14 minus 3, 11. Both D and E must be finished after 11 weeks. If I go back again, what is the latest time here that C can finish? Well, C must finish to allow D and E to take place. And D is going to take 3 weeks. So to get to 11 here, 11 minus 3, C has to be finished by 8 weeks so that D can begin and not delay the project. So how do I calculate the latest finish times? Well, the latest finish time is calculated by working from right to left, subtracting the duration activity from the previous latest finish time. So for example here, the latest finish time is 14. I work from right to left. 14 minus the duration of the activity gives me 11. So 11 goes here. Now here I face a slight challenge because when I go from right to left now, 11 minus 1 E is 10. But 11 minus 3 is 8. So which of these two numbers goes in here, 10 or 8? Well, remember this is the latest time that C can finish. And C has to finish for D to begin, and if D is going to take 3 weeks, it needs to be finished by 11. So the choice, whenever I calculate my latest finish time, I always go for the lowest option. If I don't, we're risking a delay. So we've looked at calculating earlier start times and latest finish times. Now let's move on to looking at the float. So the float comes once we've identified the critical path. So the critical path are those activities that cannot be delayed. And if they are delayed, it's going to delay the whole project. So we indicate that by making a score through the activities that are critical. So A is critical, B is critical, C is critical. Now we have D and E here, but only D is critical. If D is delayed, it's going to push the whole project back. Actually, E is not critical because we need to wait for D to finish before we move on to F. F is also critical. So we indicate the critical path by making a score through the activity that cannot have any delay. If any of those activities are delayed, take a bit longer, it's going to push back our 14-month deadline. So how do we calculate the float? Well, the float is the amount of spare time that arises between the completion of an activity and the starting of the next activity. So the only activity here that will have some float, that has some spare time, is activity E. And we calculate the float by saying, when has activity got to be finished by? And that's 11, minus how long E will take, minus when it needs to start. And that will tell us how much spare time there is associated with that activity, how much that time that activity could float by before it starts to delay the project. So the float for activity E would be 2 months in this case. So 11 months minus 1 minus 8 equals 2. E could be delayed by 2 months, which kind of makes sense when you look at it, because E could take up to 3 and it wouldn't delay the overall project. It would just finish at the same time as D. So E is not a critical activity. There could be some delay in notifying suppliers of our requirements by a month, and it's not going to delay the overall project. So we've calculated the float there and looked at identifying the critical path. Now let's evaluate the use of critical path analysis. So the benefits of CPA. the key benefit is we identify the critical path of activities. And this helps us to identify those activities that are really important to complete. And we can perhaps put our best staff, our best resources on those activities to make sure they're completed on time, so we complete the project as quickly as possible, which may be a way of gaining a competitive advantage. If we can bring out new products quickly, we can gain first mover advantage in a market. If we can complete work developing products quickly, this could improve our working capital by reducing the cash that we have tied up in stocks. This system also works very well with just-in-time and lean production. Improved efficiency can lead to lower costs, which can mean lower prices or higher profit margins. What are the limitations, the drawbacks? Well, again, it depends on the reliability or the accuracy of the data that we use. We must ensure that managers' estimates of the times each thing is going to take are actually achieved. So this might have a link to human resource management and issues such as motivation and working with trade unions. The estimates are vulnerable to outside events. For example, if one of our activities or tasks is to make an order for deliveries and there is some form of delay, it's going to upset the critical path of our project. So in this video, we've looked at calculating the earliest start times, the latest finish times, and the float for activities, identifying the critical path, so we know which activities we cannot afford to delay, which activities we need to have our best people on, and then we've, at the end there, evaluated the use of critical path analysis. That's it. Thank you very much for listening.